Welcome back to Splunk Training. So in this session, we'll be discussing about different components of Splunk. We have many components in Splunk. We'll have a brief introduction about these things, but in upcoming sessions, we'll have individual implementation components. So we'll have a detailed discussion on these components as well. Okay. All right. So we have search heads, we have deployer, indexer, cluster manager, powders. In powders, we have universal powders and heavy powders, and deployment servers and license master. Okay. So let me tell you one thing. If you want to make any server as a search head or deployer or indexer or whatever which I have listed, I'm supposed to install a Splunk software, Splunk Enterprise software on it. So if you remember, in my previous session, I had downloaded and installed Splunk software on my Linux machine as well as on my Windows machine, right? So this is the Splunk which is there in my Windows machine. So if I have to make any of the server, let's say this is my server. If I have to make this, if this server has to work as a search in a sense, I have to first of all I have to install a Splunk software on it. Similarly, just spin up another instance or another server and just install Splunk software on it, and with some additional configuration, we can make them as a deployer, right? So by default, for all these components, except universal forward, we'll discuss them in detail probably in upcoming sessions. But for most of the components, if you have to treat as a Splunk component, so we must download and install a Splunk software on them. And there are some unique configurations. Probably, for example, for searches, I have certain configurations so that will make that component as a that server as a search. And for deployer, we have a separate configurations. So if you do those configurations, then that particular server will act as a deployer. Similarly, for indexers and other components, right? So the basic point here is that we need to download and configure a Splunk enterprise software on all these servers, and based on some configurations, uh, uh, individual servers will can work as a search it or deploy it based on the configuration. Okay. We got initial idea that we are supposed to install a Splunk software, a Splunk enterprise software on all the servers to make them to work as a individual component. Okay. Coming to testing. So this is the one of the main component in Splunk architecture, because user is going to interact with this Splunk uh, with this search. For example, if I consider this as a uh, search head, I have I have certain configurations. If I just go here and if I just do distributed search, right? I'm just showing an example, but we'll have a detailed discussion in our upcoming sessions. So just by considering this uh, settings, where I have option of distributed search. So distributed search setup, and here we have option to turn on and turn off the distributed search. So by default, it is selected yes, yes. Click on save. So by this setting, we consider this particular instance as a search head, so that end user they can come, they can log into this application and they can query whatever they want. So this is kind of a search bar which we have given for the end user, right? So it is in our earlier discussion we were discussing about Google, right? It is similar to Google. Google is interacting with most of the servers which are registered for it, whereas Splunk servers will be implemented for the organization itself. So if we have around 1,000 servers in an organization, all the 1,000 servers should be pointing to my Splunk component, a Splunk server, so that we'll be storing them in a Splunk database, and with the help of this search head, with the help of this search head, we'll be querying the data. We are getting back the results from the Splunk. So basically, this is the GUI section. This is the user interface which will be given to the end user so that he can perform some query and he can get back the results. So what is the first step to make this as a circuit? First of all, I need to create an server or instance, and on top of it, I need to uh, install Splunk Enterprise software, and with the help of some configurations, I can make it as a subhead, right? So, so basically, as I mentioned, it does interact with the Splunk. It does interact with the end user. So, and it distributes the user request to the indexer. See, basically, we'll have searches. Of course, we can have multiple searches. With the help of load balancer, we can route those traffic, and that can be distributed to searches. That we'll discuss later. And whenever user hits some request, right, and this particular search head, right, which will connect with indexer. We will discuss what is indexers in a while. So basically, this is the server which can store the data. It can store some external data, which is of your application data here based on some data retention policy. So whenever user asks for something, and this particular subset will get in connect with indexer, and it get back the results, and it does display the results in subset. Right. So basically, whenever a user, because multiple users will be interacting with subset, so as and when user gets a request, then this subset will distribute the user request to the available indexer to get back the results. So with the help of this circuit, I can analyze and I can visualize the data in a very good manner. We'll have a data discussion on these, creation of reports and alerts, kind of a visualization. But for now, let's consider Surfshed as it's a main component. We are supposed to install Splunk software on it, and we'll have to make some configuration to work as a Surfshed. And basically, it will be given to the end user, so end user can interact with Surfshed and he can query something. And how does Surfshed get back the results? In the sense, it does connect with the indexers which are available, whereas indexers are the main component which can store the data of a remote machine. Okay, so this is about searches. And coming to deployer. Okay, so let's say here, if you come to searches, have three searches here, right? So sorry, here we have one search. So typically, I can have multiple searches by creating a cluster. We'll discuss about cluster in upcoming sessions. So we can create subset clustering itself. Cluster maintains minimum two subset servers. So it can differ based on our requirement. So minimum we can have 3 or 4 subsets within the clustered environment. Okay. For example, let's consider these in this scenario. I have three circuits. I have three circuits. Now, let's say if I have certain common configuration that needs to be updated to all the circuits. So if that is the case, I need to I need to log into this machine and I'll have to make some changes. Similarly, I'll have to repeat the same here and as well as to the third circuit as well. Whereas, what if we have a option to monitor these circuit members by the captain, which means this will act as a master to these searched slave members. We can consider them as a slave member, searched slaves, and all these slaves are reporting to uh, master. That component in Splunk terminology, we call that as deployer. So let's say if I have to make some changes, if I have to push some app configurations and everything, I'll just create it here and I'll use some command. With the help of that command, I can distribute the same configurations and everything on the respective clustered member. This is the importance of deployer. So which means it is again a deployer, again a Splunk component. In order to make this server the deployer, I need to download and install this particular Splunk Enterprise software on it, and afterwards, with the help of some configurations, I can make this component as a deployer. And what exactly deployer will do? So it does help us in pushing the common configuration across the all the clustered members. So individually, I don't have to log in and I don't have to manually, configure everything. Instead, I'll just make use of this component, and all these layers are registered to this deployer. And whatever the configuration which I'm writing here, everything can be pushed to all the cluster members, right? So this is about the deploy. This is the second component. Coming to third component, this is indexer. This, as I mentioned, this is the main component in Splunk. If my Splunk environment is working fine, if and only if my indexer performance should be good. So if my indexer is working fine, if I don't face any issues on the indexer, then 80% of the cases will not face any issues. Okay, what is indexer? Again, indexer is a Splunk component. If I have to make this as an indexer component, first of all, I need to spin up a EC2 instance or a server. Then on top of it, I need to download and install Splunk Enterprise software on it. And with the help of some configurations, I'll make this machine as Splunk indexer. Okay. So when I say indexer, it is the component which will store the data from the remote application. These remote applications can be your Linux machine or your Apache Tomcat server or any of your applications which are hosted within your organization. In most of the cases, we can also we need to store the data from routers and switches and many other networking devices, right? Even those data can be stored under indexer. So this is dedicated component to store the data across all the applications or networking devices or whatever the devices you are interested in. Okay, so how exactly it does store the data? See, uh, Splunk indexer will store the data in terms of buckets. We will discuss them in detail, what is buckets and how exactly buckets works in Splunk indexer, and what are the data aging, everything will have a detailed discussion. But just assume that this is the indexer is a place where we can store the data. How can we store the data? So with the help of creation of indexes. For example, I want to store a Tomcat logs, right? I want to store Tomcat logs. So in order to store Tomcat logs, what I will do, I'll just create a separate index, separate folder called a separate index in indexer, so that it will be easier for me to identify. Okay, this particular such a Tomcat log are getting stored in Tomcat index. And in another case, I want to store some network devices logs. In that case, what I will do, I, within the indexer, within the indexer, I will create a index called network index, and I'll store those data under network index. Okay. And later, I want to store some external applications data. For example, syslog data. So what I will do, I'll just create an index. I'll just create an index under this indexer called syslog, and all the syslog related data can be stored here. So I have this visibility on my indexes. I'm very much sure that these syslog related data are getting stored in syslog index. Networking related data are getting stored under network index. Tomcat related data, Apache Tomcat related data are getting stored under Tomcat index. So in this way, we are segregating our data for our future purpose. See, it is very simple, right? So why do we need to have multiple tables in a database, right? So will not have a single table, right? So just to have a segregation, we'll create, for example, employee is a table, and organization is a table, right? Roles is a table, users are the table, right? So why do we create different tables? Just to maintain, just to have a clarity on the data are getting stored. under a particular table. So similarly, we are creating a separate table. So we can try to refer each index as a table, right? And each table will have the relevant information so that it will be easier for me to search in future. And within index, within index, folders are getting created. We will have a detailed discussion going forward. In short, how to this is the third component of a Splunk, and how to make this as an indexer. I need to spin up a server or any cloud instance or EC2 instance, and on top of it, I need to download and install a Splunk software, something like this. See, all the components will have a similar GUI, right? You will have a look and feel the same thing, but based on some configuration, each component will work differently, right? So I allow to install a Splunk software on it, and afterwards I need to make some changes on the configuration so that this particular component, this particular server will act as a indexer. So basically, indexer is a place where which will store the data from across all the remote applications. How do we store the data? So just to have a clarity on our data, so we are creating different folders or different indexes based on the incoming data. And within each index, we'll have a different folder. We'll have a data discussion later on. Okay, this is about indexes. Okay, this is the third component. Coming to the fourth component called cluster master. This is similar to deployer, what we discussed for circuits. So for circuits, all the circuits are acting as a slave to deployer so that the common configuration can be pushed, right? So similarly, if I have to maintain, if I have to push some configurations across all these three indexes, so in real time, in most of your projects, definitely will have more than 10, 20, 30 indexes based on the data volumes, right? So in that case, if you have more than 20, it will be difficult to maintain the common configurations across all the indexes just by logging in and making the changes, right? So we may forget something, and it's always we do kind of a typo error and everything. So instead, we have a facility in Splunk. What exactly it does, we are creating a cluster master or master node we call, and we'll install the necessary software. What exactly we need here? Again, for cluster master also, we need to install Splunk software, and with the help of some configuration, we'll treat this as a cluster master or master node. Now, what will happen? All the indexes which are there in your cluster environment, all are reporting to this cluster master, right? So, which will act as the master, and if you need to push some configuration or common configurations, we'll just execute some command. So, with the help of that, all the necessary configurations are getting loaded under the indexes in a clustered environment, right? So, cluster master or master node is a master which will help us in pushing the common configuration to all the indexes, right? This is about cluster master. And coming to the next component, this is a very important component in Splunk. These are all forwarders. As I mentioned, we have universal forwarders as well as heavy forwarders. We will look into it, know what exactly universal forwarders and heavy forwarders. Okay. Uh, let's say I have a machine. Okay, let me just draw something here just to have a better clarity. Let's say this is my computer or this is my server. Let's say this is my application server. I'll just say this is my app server. And I want to see the log, see whatever if this is a computer, if this is a machine, right? If this is my server and this is a machine, then definitely there will be some sort of logs get generated, right? So, and I'm just making this as a web server, then definitely there will be logs under WAG log under this folder. Probably can say under messages. So I want to read the log under this log. Probably here we'll have Tomcat. Okay, I want to read this particular log under this app server. Now, this is completely a different server. I'm not sure whether it's a Linux machine or Windows or Mac based or any kind of operating system. I'm not sure. Right? First of all, we need to understand. We need to get the information. Know what kind of a system it is. I need to get information about the operating system details. Once we get those details, then I need to install something called as forwarder, which means universal forwarder. Again, it's a universal forwarder is a again it's a software which is available in Splunk. It's a lightweight software. So this I need to download this universal forwarder from Splunk website, and I need to download this particular software on this application server, and I with the help of this universal forwarder, right, I will monitor this particular standard, or I'll just monitor where log or Tomcat. Okay, so this is the way we are going to use in order to monitor or in order to get the logs from this application server to universal forwarder. So what exactly we are doing here? Let's say we have a machine and I want to read some data from out of this machine, and I know where exactly my data resides, where exactly my logs or application data or machine data resides. So in order to establish a connection, see, this Splunk to Splunk, this is fine. Let's say this is my Splunk index. Splunk, I'll just put it in a simple term, Splunk. Because as I mentioned, I need to store the data from this machine to this machine, right? So here we'll create something called as indexes. Within that, here we'll have it in Splunk. We have something called as indexes, and within the index, I will create. I'm just creating something called as index. That's what I just explained, right? So this is the index. As this is a application server Tomcat logs, I'll just say index is equal to Tomcat. So I've just created a index under indexes in a Splunk environment. So with the help of with the help of this universal forwarder, I'm just what I'm doing here, getting the data. I'm just trying to read the data with the help of universal forwarder. And once we read the data, I'm just forwarding this data to Splunk indexer to the respective indexes. This is how we are going to store the data with the help of universal forwarder. Because see, this application server it is comprised with many software, but in order to establish a connection from the application server to your Splunk indexer, we need a one Splunk component, or we need a agent that needs to be installed on this application server. So this agent or universal forwarder will, once we install that one, then we'll have to make necessary configurations. We'll have to make necessary configurations on universal forwarder. Then this particular data can be read and it can be transferred or it can be stored in Splunk premises. These are the functionalities of universal forwarder. In short, universal forwarders are to be installed on the application server on, I mean, from which server you want to read the data on those application servers, you're supposed to install a Splunk component called Splunk Universal Forwarder, and you need to make some configuration so that these data can be read with the help of Universal Forwarder, and same can be indexed or stored under Splunk indexer with the help of the index. As this is the Tomcat, and it is as I'm storing these data under Tomcat, it is easier for me to identify the data while searching. Right. So similarly, if I want to have another server called something called as database server. Okay, this server, and I want to read the logs from this database server. So what I'll do again, I need to install universal forwarder on this server, and I need to mention from where you need to monitor, right? And afterwards, you just enter the path of the log which needs to be copied over. Then this particular universal forwarder will help me in transferring or copying or storing the data to Splunk indexes. In this case, what I will do, I will create a separate indexer. I'll see. I can always store under Tomcat, but it will be clumsy, right? It will be very much difficult to understand. Let's say in order to debug some data, it will be difficult. So that's the reason. For each and every aspect, I'll try to create a separate index. So here, I'll just name this as index as DB, so that if I want some data which are related to this particular machine, it is very much handy. I know the index name or the place where I have stored, then it will be easier for me to query the data from this particular index. Right? So this is nothing but a indexer. Sorry, this is nothing but a universal forwarder. And we do have heavy forwarders, right? So we will discuss them. Let us not get confusion at this point of time. So basically, forwarders, whenever we hear something called as forwarder, so we need to install these forwarders on the application servers or whatever the servers from where we are referring the log. Then we need to make certain configurations, and with the help of those configurations from the universal forwarders which are hosted on a particular server, the logs can be read and stored in a Splunk environment. This is about universal forwarders. We will discuss on heavy forwarders in our upcoming sessions. Okay. Again, the same concept. So definitely in the organization, definitely will have thousands of application servers or thousands of devices which are hosted within your organization. In our case, if you have 1,000 applications or 1,000 servers and all the 1,000 servers that needs to be configured, something like this, which means I'm installing 1,000 universal forwarders across 1,000 applications, right? So in that case, if I have to push some common configuration across all the 1,000 servers, then it will be difficult, right? So that is the reason we have something called as deployment server, right? So with the help of the deployment server, so again, how to make this server as a deployment server? I need to install Splunk software, Splunk enterprise software on it, and afterwards I need to make some configurations. With the help of this configuration, I can treat this machine as a deployment server. So this is a configuration manager which distributes the apps and configurations to the member of a server class. What is server class? Again, server class consists of a deployment client, a collection of clients, a collection of application servers are called as server class. Okay, and with the help of these deployment servers, we can distribute the applications or apps or configuration to the universal forwarder as well as to heavy forwarders, right? So this is the job of deployment server. So how to make any server as a deployment server? I need to install Splunk software on it, and with the help of some configurations, we can make this as a deployment server. What is the job of the deployment server? If I have to push some configurations to all the clients or all the application servers, then with the help of this, I can push it. So, which means this is acting as a master node, and if you have 1,000 application servers, all the 1,000 applications servers should be listening to this deployment server. It means all the 1,000 servers are slaves to this deployment server. Right? We will be implementing deployment servers, and we'll have many forwarders, and we'll try to read the logs. Okay. And coming to the last component called license master. See, in most of our organizations, It all depends on the data which we are receiving from the application. It all depends on the data volume. Typically, we'll have, we'll have to purchase a license. We'll have to purchase the license based on the data volumes we are ingesting. Definitely, if you have, if my data ingestion per day is 100 GB, which means every day I'm injecting, I'm storing 100 GB of data on indexer, then I need to raise a request with Splunk. I need to explain this is what my daily consumption, or this is what the license, or this is what the volume which I'm daily ingesting. So based on the volumes, they will set up a licensing and they will send out an email or whatever the communication you need. So we'll have to pay some sort of amount so that we are authorized to store the data in a Splunk indexer. So which means all the Splunk indexers, including search heads, are reporting to this license master. So this license master will have a authority, will have a eye on all these indexers. So if something goes wrong, which means if you are exceeding some daily limit. So in our case, our daily limit is 100 GB per day. If you are exceeding that, then immediately we throw an alert to the respective indexer so that we can think of either increasing the license or we can think of eliminating some unnecessary noise or unnecessary data. Right? So we can create a license pool and we can configure all the indexes there, and all these indexes or license pool are pointing to license master. Right? Will have a detailed discussion on this. Right? Okay. So again, in order to make this server as a license master, again install I need to install unnecessary software, which means a Splunk software on it. And afterward, I need to make some configuration. We'll see all these things, but yeah, this is what if you just configure this section, see based on license, right? So if you are requesting Splunk to give, if I'm requesting Splunk to have 100 GB per day license, then they'll charge some sort of amount, and later that they'll send out an email, or that particular license will be in a XML format, right? So we'll just, it will be ending with dot license, and we need to open that file, and we'll have to um, upload the license here, so that this particular server will act as a license master. And with the help of this one, so we can always, take a cluster we have, we can always route or index which are pointing to this license master. We will see that, right? No issues. So which means if we have multiple indexers, all these indexers and searches should point into this license master. Okay, this is about license master. So let's summarize. Okay, before that, we have certain common Splunk codes that needs to be taken care while designing your Splunk architecture. So which means if your Splunk component is working as a search head, then it needs to be it needs to be enabled with 8000 because this is a Splunk web core. And for most of your Splunk components, for most of your Splunk components, this 8000 must be needed, because this is how even I can just log into this machine. If let's say if this machine is my indexer, I can just log into this machine with the help of this port 8000. And if you just consider this as a search head, even this 8000 is needed. Or even if this is needed for, if you want to configure a deployment server, then I need to open a deployment server with this configuration. So this 8000 is a common port which needs to be opened in. It has to be opened in as a inbound rule, right? Okay. And 8089. This is the management component, right? Okay. I was saying from the universal forwarder to Splunk environment, the data are getting stored. How exactly it does store the data? With the help of a port called 808. This is the Splunk management port. So this has to be enabled on both the sides so that with the whatever the data which is captured here, all the data are stored with the help of 808, 8089 port, right? So this is the communication port or this is the management port. So this needs to be taken care and we must know in which component we need to enable, right? Okay. In our case, if you want to store the data from application servers, I need to install universal forwarder, and from universal forwarders to indexer, the data gets stored with the help of the port 808. And similarly, Splunk indexing port, right? From universal forwarder to Splunk indexer, if I have to store some data, I need to make familiar about this port, which is 9997 port. So if I just configure 9997 port on this machine, you see, if I just go here, now click on forward and receiving, and click on configure receiving, and just enter new receiving port, right? And see, here it is there. So if you just mention 9997, then with this configuration, please understand, this is the configuration will make this instance or this server as indexer. Now I can consider this indexer as I mean this server as indexer because I've just enabled the receiving port which is 9997. Why did I enable 9997? Because this is as per the Splunk documentation. This is the Splunk indexing port. Okay, so now this machine is nothing but the Splunk indexer. Okay, so this is how it works. Now coming to 8080, this is the Splunk indexer replication port. Okay, so indexer replication port in the sense in future we'll be implementing multi-site indexer clustering. So which means whatever the data which is there in one indexer, if my requirement is to have multiple copies of the data across different indexers, then this particular copies of data from one indexer should get replicated to another indexer. How exactly data replication happens between the indexers with the help of code called 8080. Okay, and 514 typically, if you are referring, if you are reading some network logs or via TCP or UDP protocol, then we'll use this 514, which means let's say this is my some network device, and from this network device I want to read the log, and let's say this is using UDP protocol, then I need to enable 514 port on this machine so that I can read the data which is of UDP or TCP protocol. Okay? So these are all some important common ports we use, and this is your final Splunk architecture. So basically, I've just tried to bring all the Splunk components here, but again, it is not a clustered environment. We'll be implementing that clustered environment in our upcoming session. Now, let us understand how it works. So as I mentioned, searches are given to the end user. So end user will have access to these searches. So typically we'll just implement a load balancer, and that particular load balancer will be pointing to all the searches. So we'll just give a domain name, a kind of a DNS with a beautiful name, and users will be happy to query the data by using that domain. So in turn, that particular domain or load balancer are pointing to these searches, and user will query something, and this particular query will be accessed with the help of indexer. Okay, see the data already there in the indexer, and users will just make use of search it, and they'll just query something, and this search it in turn pass this request to indexer, and if it finds the data, then indexer will return back the data to search it, and users are able to see that. How exactly the data are getting stored here? See, so this is what I have shown here. These are all different universal forwarders, which means, let's say this is a Windows machine, this is a Linux machine, this is a Apple, let's say this is a firewall, syslog devices, right? All these devices needs to be configured with universal forwarders. Sometimes, if not, we can with the help of Hex or with the help of syslog, we can read the data from different applications. Just to make it simple, let's consider on all these devices, I'll have to individually configure universal forwarders on these servers. And with the help of this universal forwarders, then Splunk knows how to get the data from here. So if let's say if user needs a Windows related data, then this particular Windows machine that needs to be the data should be read, and it should be stored in Splunk indexer. If we have this data here, then user can just query index is equal to Windows or whatever the index name we have given, and this request will come to indexer, and indexer will have the data, it will give back the result. Right? So the first point would be all the universal forwarders or heavy forwarders should send the data to the indexer, and once we have this data, then user with the help of search head, they'll query the data, and that particular request will come to indexer and to appropriate indexes as well. And once it finds the data, it will give back the results to search it. And similarly, if we have some common configuration that needs to be pushed all the searches, then deployer is the best component. With the help of the deployer, we can just push those configurations across all the searches. So similarly, cluster manager. So if you want to push the common configurations across all the uh, index appears, then cluster manager will help us. So similarly, the deployment server is a master to all the applications. When I say applications, are for all the universal forwarders and heavy forwarders which are installed on the respective application servers. And license master will definitely will have eye on searches and indexer, and as and when it finds some breaches, it will always throw an error, right, on the respective indexer. Okay, so this is about your Splunk architecture and the different Splunk components. So in the upcoming sessions, we'll have detailed discussions on data onboarding and all. All right. So this is what I have. Thank you.